everyone, good morning. So once again, we're meeting for the second phase of our module. Last time we have discussed about determining the conditions that can make a quadrilateral a parallelogram. So once again, this is your teacher friend Liss. I will be discussing the second topic, which would be all about using the properties to find the measures of angles, sides, and other quantities involving parallelograms. So the title of our MELC 2 module, use properties to find measures of angles, sides, and other quantities involving parallelograms with our learning competency with code. The learner uses properties to find measures of angles, sides, and quantities involving parallelograms under the code M9GE-3B-1. So this one would be all about the one that you have been waiting for, the most awaited part, which would be solving. So last time we have illustrated the quadrilaterals, the special types of quadrilaterals with its figures and definition. So today we will be talking about parallelograms, which we have defined on the first phase or on the MELC 1 module as a quadrilateral that has no equal sides, wherein the angles are not at all equal, but it has two pairs of parallel sides. Alright, and those two pairs of parallel sides, so we will be using parallelogram in our figure using the properties of parallelogram. Now these properties was actually taken from the conditions that we have discussed on the very last part, when can we say that a quadrilateral is a parallelogram based on the condition. If you can still remember, the first condition there was a quadrilateral is a parallelogram if the two opposite sides are congruent. We only took 5 among those conditions, so the first property is actually the same. First property is in a parallelogram, any two opposite sides are congruent. So all we have to do first, in order for you to easily understand everything or the terminologies that we will be using before we can get to the solving part, are this. The first one are opposite. When we say opposite, gato bangayang ilanga, whether it's a side or angles. Consecutive, pasunod nga angles, like for example in my figure here, I have here a parallelogram SPQR, wherein the opposite side
line segment SR and line segment PQ.
Q. Alright, so if we are talking about two opposite angles along its diagonal, that will be the angle SQ and the angle P and the angle R. So there are two opposite angles along its diagonal. So you must remember those two terms, because that would actually give you a background, or that will make your solving easy. So this is all about logic and analysis. Then the rest will just follow or go with the flow. Then we have congruent. When we say congruent, if we are referring to two congruent sides, that means if they are congruent, whatever the measure of the other line segment, its pair is actually the same. Like for example, in the same figure here, or illustration of parallelogram SRQP, wherein our opposite sides are line segment SR. Let's say line segment SR measures 6 centimeters, so its pair is line segment PQ, should also be 6 centimeters since they are both congruent. Then the next term is consecutive. So I have defined that one. Consecutive, gani pasunod. So like for example, it doesn't matter where you start, as long as you don't skip the vertices, dapat pasunod. Like for example, in our figure SRQP, we can either start with the line or angle S and angle R. There are two consecutive angles, or you can say angle R and angle Q. They are also two consecutive angles. And supplementary, those two consecutive angles, when you add those two together, when it terms to parallelogram, it add up to 180 degrees. That is why it is called as supplementary angle. So just remember that one, and the rest are just easy. Okay, so let me read to you the 5 properties of parallelogram. I will just make it short and easy for you. Actually, wala na kita load, but we'll just make it simpler, in a simpler way so you can understand it clearly. The first one is the first property in a parallelogram: any two opposite sides are congruent. So you can easily remember that one. The second is, in a parallelogram, any two opposite angles are also congruent. Number 3 property, in a parallelogram, any two consecutive angles are supplementary. That's where those two angles, when added, will give you 180 degrees.
The fourth one,
Diagonals of a parallelogram bisect each other. So you can see that one, if you draw or connect two opposite angles along its diagonal, you would have two pairs of opposite angles, and you will have two line segments connecting both. That will be intersecting lines, and which we call the diagonals that bisect each other, leaving you two congruent parts. And the last one is, a diagonal of a parallelogram forms two congruent triangles. So you already know that during your 8th grade in math, wherein if you divide a rectangle or a piece of bond paper, whether it's a long or short, along its diagonal part and tear it off, it will give you two congruent triangles. When we are referring to congruent shapes, that means they do have the same exact size, that when you put one on the other, it will fit exactly, because they are said to be congruent triangles. Alright, so basically these are all the guide for solving. So it doesn't matter which form of the measures that will be given to us by every problem, as long as you have remember, or you can remember all of these 5 parallelogram properties, and everything will come easy for you. Alright, so let's start with the very first one. The given figure, again, let's use the same illustration. Parallelogram here,
SRQP.
wherein our line segment SR measure 6.2 centimeters. Since parallelogram property number 1 says that in a parallelogram, any two opposite sides are congruent. If line segment SR measures 6.2 centimeters, that means the other line segment at the bottom, which is line segment PQ, since they are congruent, that means it also measures 6.2 centimeters. What if the measure of the line segment SR is not in the form of the whole number? So it will be the same thing, which we'll be talking about on the second problem from your module that was given to you, wherein it is in a form of algebraic expressions. All you have to do, so that you won't be confused, is you must start with a congruency statement. So you would know that the measure of the other line segment comparing to its pair is congruent. So you can put an equal sign in between two algebraic expression. So let's get the ball rolling, and let's proceed to number 2 question. Alright, now let's proceed to the second example. Second problem from your module, you have parallelogram there, ABCD. Alright, with the following given measure, it is not given to us as a whole number, but in a form of algebraic expression, which we need to solve for the missing value for the variable x and y. So let me read to you all the given sides here. Line segment AB is equal to 3x minus 5 centimeters. Line segment BC is equal to 2y minus 7 centimeters. Line segment DC or line segment CD is equal to x plus 7 centimeters. And line segment AD is equal to y plus 3 centimeters. You are being asked what is the value of x and the value of the variable y. In order for you to find out the measure of each side, we need to find out the value of the given unknown variable. So we would start with the x term. So the only side here that are in the form of, or that has an x variable, are this one, the line segment AB and the line segment DC. And remember, when naming the line segment, you can either start either way from D or to C. For example, here, because it will give you the same exact line. Because from the book, it was quoted as line segment CD. All right, just making sure that you won't be confused. Okay, so now let's start writing the congruency statement to make it easier for you. We all know the fact that this is a parallelogram, and a parallelogram has two pairs of parallel sides, and those two pairs of parallel sides are line segment AB and line segment DC. I will just use DC. Line segment DC. And another pair is line segment AD and line segment BC. So let's start with this one, with the X term. Line segment AB, we know that line segment AB is congruent to line segment DC. Alright, so if you start from congruency statement, the rest would follow. All you have to do is just proceed with substitution rule. So what is the value of the measure of line segment AB? It is in the form of 3x minus 5. So let's write here 3x minus 5. So which is equal to the length here. So whatever the output or the outcome of this solution must be equal to the measure of the above line segment. Line segment DC is equal to x plus 7. So we're going to substitute x plus 7 to line segment DC. So we now have the equation. 3x minus 5 equals x plus 7. So how are you going to solve this one? The very first thing that you must remember, or the second thing that you must remember other than writing first the congruency statement, is this. You have to group similar terms. So what are those similar terms? When we say similar terms, you cannot add two different terms, right? Just like, for example, in adding objects, you can only add objects if they are similar. Like, for example, in a box, there are 3 apples and you add 2 more apples. You can just say that the total of the apples inside are 5 apples, right? You cannot just add 3 apples and 2 bananas. You cannot put the total as 3 apples and bananas because you cannot add 2 different objects. Same with adding terms. You can only add similar terms. And when we say similar terms, not just that they are both having the same variable, which is x, but you also need to remember that the exponential value must also be the same. Our 3x, automatically our x variable has an exponent of 1. Same with the x, it has an exponent of 1. So we can quote them as similar terms. So let's group them together, and by adding together these two, the symbol for this one, this is positive x, all right, and it is on the right hand side of your equation. You're facing this one, so this is the right and this is the left. We have to move it to the other side or to the left hand side of your equation. The sign or the sign of this positive x will actually change. So instead of positive x, it will turn into negative x. So just remember that. So it will be 3x now minus x. Are you following? Then what will be left is the negative 5 constant. We cannot subtract negative 5 from 3x. So we have to pair it with its similar term, which is the constant on the other side, which is positive 7. So we take this x off. What was left here on the right side was positive 7. Alright, and moving this negative 5 to the other side, same thing with the x. If you move it to the other side, from the left to the right hand side of your equation, the negative sign would turn into positive. So that would become positive 5. So now our equation, after grouping the similar terms, I have here 3x minus x is equal to 7 plus 5. So 3x minus x, we will have the answer of 2x then. Is equal to 7 plus 5 will give you 12. Alright, we still have the variable here. We haven't solve it yet? So as see, the numerical coefficient of 2x, which is 2, is divisible by 2, and the 12 is also divisible by 2. So we can simplify our equation by dividing both sides. So whatever number you divide in here from the left, it will also be the same value that you will be dividing onto the right side. So 2x divided by 2, if you divide it by 2, cancel lang 2 mo, x will be the one left. And 12 divided by 2 will give you 6. So now you already have the value for your x, which is equals to 6. So in order for you to find the exact measure of your line segment AB, all you have to do is substitute this number 6 to x variable here. So that will be 3 times 6 minus 5. 3 times 6 is 18 minus 5 will give you 13. And this is in centimeters. Alright, so you already know the answer, exact measure for line segment AB, which is 13 centimeters. Since line segment AB is congruent to line segment DC, this x plus 7 should be equal to 13 centimeter. And it has the x variable, which we can substitute the value of x, which is 6. So that will be 6 plus 7 will give you 13. Now you already solved for the value of x here, which is now 6. Now we're gonna need to find the value of y by solving this side right here, line segment BC and line segment AD. So we will be following the same procedure. We will start from the congruency statement. So what are those two parallel sides with the y terms would be line segment BC, which is congruent to line segment AD. Substituting the values, line segment BC is in the form, or its measurement is in the form of 2y minus 7, which must be equal to the measure of line segment AD, which is in the form of y plus 3. Alright, we will be adding the unit of measurement on the final answer. 2y minus 7 is equal to y plus 3. This is now our equation. Alright, so in order for us to solve this equation, we have to group similar terms. Again, I have discussed what are those similar terms already. We have 2y and y. Moving positive y to the left side, it will turn into negative. So that will be 2y minus y. What will be left is negative 7. It needs to be transferred to the other side. Plus 3 will be left here, so that's positive 3. Negative 7, once you transfer to the right side, it will turn into positive 7. So that will be 2y minus y will give you y is equal to 3 plus 7, 10. So now you already have the answer for the value of y, which is 10. So in order to find the measure, the exact measure of line segment BC and line segment AD, which are two congruent or parallel sides, you have to substitute the value of y, which is 10 here. So instead of 2y minus 7, since you already have the value of 10, that will be 2 times 10 minus 7. 2 times 10, 20, minus 7 will give you 13. Oh, this must be a rhombus. 13 centimeters, same here. Y plus 3, that will be 10 plus 3 will give you 13. Alright, so now I found out that since all of these sides having the same exact measure of 13 centimeters, so that literally means that that means our figure is a rhombus because it has 4 equal sides, which has the measure of 13 centimeters. Now let's have another example. I know that you have a different example there, given problem from your module, but I just want to try different examples so you will be able to explore what are the other possible questions wherein we can apply the properties of parallelogram in order to find the measures for every angles, sides, and other quantities involving parallelograms. So I have here parallelogram A, B, C, D. And I have here given measures for the angle A represented by variable x. And the measure of angle B is 2x. You are being asked to find out the measures of your angle D and angle C. Let's say angle D is unknown, and angle C is unknown. And also, we wanted to find out the exact measure of the angle A and as well as the angle B. So what are we going to do? What do you remember about the parallelogram property? Parallelogram property number 2 says there, or in a parallelogram, any two opposite angles are congruent. So we have here opposite angles, which are angle A and angle C. So that means whatever the measure of this angle A is also equal to the measure of your angle C, right? And what the other pair is angle D and angle B. So this angle B is also the same measure here, which is represented by 2x, but we still need to find out the value for x. So how are we going to do that? We will be applying the third property, which says that in a parallelogram, any two consecutive angles are supplementary. So once again, supplementary angles, when you add those two together, it will give you 180 degrees, right? So therefore, x plus 2x, or we'll start first, angle A plus angle B must be equal to 180 degrees, right? Wherein our angle A is x, angle B is 2x. So x plus 2x must be equal to 180 degrees. Solving it algebraically, all you have to do is x plus 2x will give you 3x is equal to 180 degrees, and the value for your x would be 180 divided by 3 will give you 60 degrees. So now you already have the value specifically for the value of x. If angle A is x and x is equal to 60 degrees, that means your angle A is equal to 60 degrees. And since angle A is the opposite of angle C, and opposite angles in a parallelogram are congruent, that means our angle C is also 60 degrees. Now let's go back to angle B. Substituting the value of x, which is 60, so 2 times x is equal to 2 times 60 will give you 120 degrees. Yes? So since angle B is the opposite angle of angle D, which according to number 2 property, we're in a parallelogram, any two opposite angles are congruent. So that means angle D is also the same as 120 degrees. Yes? So basically, we have applied the second rule, which is in any parallelogram, any two opposite angles are congruent. And we have identified those opposite angles in our figure. And the third property that says in a parallelogram, any two consecutive angles are supplementary, which we have actually defined that supplementary means the total measures of the two consecutive angles or adjacent angles are equals to 180 degrees. Now let's proceed to another example, which is more trickier, so you will be challenged as well. Alright? Now let's have another example, which is a lot interesting than the previous one. So we will be using the same illustration that I've used a while ago. I have here parallelogram, if you can see. I have here parallelogram A, B, C, D. And as you can see here on the figure, I have here two diagonals. So you already have an idea in mind that we will be using the fourth properties of parallelogram that says the diagonals of a parallelogram bisect each other, like this one. Alright, so our given measure here provided by the problem, our angle A, or angle, let's use 3 letters to name the angle. Angle OAB is 30 degrees. The angle DAO is 45 degrees. The angle C, or angle DOC, is 105 degrees. The question is, find the measure of the angle AOB. So that means this one right here. Alright? So since the angle O is vertically opposite to this one on top, so you can see here, the one I'm pointing on here, applying the second rule or the second property of a parallelogram that says in a parallelogram any two opposite angles are congruent. So since angle O and this angle right here are vertically opposite, the one on top says 105 degrees, that means angle O is also 105 degrees. So both of this one, because these two are two congruent triangles divided by the two diagonals of the parallelogram. Now, as you can see, we have here 105 degrees, and I have here the angle OAB, which has 30 degrees. And this one right here forms a triangle. The total degree measure of a triangle is 180 degrees. Going back to the question wherein you are being asked to find the measure of angle ABO, which is here. In order for you to find out the measure of the angle ABO, all you have to do is just take note. The sum of the measure of the degrees of triangle is equal to 180 degrees. We have here 30 degrees, we have 105 degrees, and we're just missing one angle measure. All you have to do is 30 plus 105, that will give you 135. 180 degrees, which is the total. We'll add it here. 30 plus 105 degrees plus x, let's name it as an x, must be equal to 180 degrees. Or the angle OAB plus angle AOB plus angle ABO must be 180 degrees. So we already know the measure of angle OAB, which is 105 degrees, and we already know the measure of the angle OAB, which is 30 degrees. We're only missing one. So 180 degrees minus 135, it will give you 45 degrees. So this one right here is 45. Now, all the angle measures of the three sides of the triangle are now complete. So if you check, 30 plus 105 plus 45 will give you 180 degrees. So now it was solved. The measure of, let's put a small letter M to indicate that we are looking for the measure of angle AOB, which is 105 degrees. And the measure now of angle ACB, which we are looking for. So take note of the center letter, which is C. So let me point here. Angle ACB. So we are going to find out the measure of this one right here, the angle ACB or the angle C. Since angle C or angle ACB is opposite of the angle OAB, which is 30 degrees, this one right here is also 30 degrees. Get? Now you can see, because according to the rule number 2 or the property of parallelogram number 2, wherein it says that in a parallelogram two opposite angles are said to be congruent. The opposite angles right here, without looking at the diagonals, we have angle A and angle C. So whatever the measure given here, it is also the same as for the measure of the angle C. If this is 30 degrees here, this must also be 30 degrees. If this is 45 degrees, this is also 45 degrees. Alright, so that will leave you the exact measure of 45 plus 30, which is 75, and here 45 plus 30 is also 75 degrees. So once again, we have applied two rules, the second one and the fourth one. Alright, so the measure of the angle ACB is 30 degrees. So now everything is complete. Alright, now let's wrap up what we have discussed for the whole Mathematics 9 Quarter 3 MELC 2 module, which has the title of Use Properties to Find the Measures of Angles, Sides, and Other Quantities Involving Parallelograms. So the whole discussion rotated in solving those missing angles, sides, and other quantities that were asked, from all of the examples that I have shown to you. And those 5 properties are, namely, the first one, in a parallelogram, any two opposite sides are congruent. Right? So that means the measure of the two opposite sides are always the same length. Number 2, in a parallelogram, any two opposite angles are congruent. That means the measures of those two opposite angles are exactly the same measure. Number 3, in a parallelogram, any two consecutive angles are supplementary. So we have discussed that one, that adds up to 180 degree measures. Number 4, the diagonals of a parallelogram bisect each other, just like the one shown here on the last problem. And number 5, the diagonals of a parallelogram forms two congruent triangles, which here in last example, which is a lot trickier. And by the way, I do have a trivia for this one. We solve almost everything that were asked, except for 2 things. If you got the answer for the first one, which is also congruent to the other unknown, then you will have the same exact answer. So look at this illustration that I have here. We have solved for the missing angle measure of angle ADO, right? Which is 45 degrees, which is congruent to the degree measure of the angle ABO, which is also 45 degrees. But we haven't solved for the other half because we have divided this parallelogram with the use of 2 diagonals that bisect each other. That forms 4 triangles. And we have missing measures here which are not being asked from the question. So I want you to practice solving and find out what is the remaining measure for this one, the other half of the angle D measure, which would be the same here for the other half, or the half of the measure of your angle B. So you have all the clues in there. All you need to do is just to apply the logic, apply those properties of parallelogram, whether it's number 1, number 2, or up to number 5, whichever would work for you. I have given the rest of the answers. So good luck. So now I am pretty much sure that after applying the properties of parallelogram, you are now ready to prove the theorems for different types of parallelograms unto your next module, which would be your MELC 3 module. So good luck. Thank you so much for watching, and I hope that you have learned a lot from me. And I'm also hoping that you would check the screenshot that I will be attaching together with this video so you can make a guess, or you can gauge your knowledge on what will be the next topic which you will be getting for your next module. That will be tomorrow for your MELC 3 module. So please stay safe. God bless. Once again, this is your teacher friend Liss saying thank you so much and have a great day ahead. Bye.